Hi class, this is Professor Smith. I'm going to be doing a movie on the sample final for Math D. The first problem says solve for W and the equation, and you have negative 3 times the quantity, negative 6W plus 8 minus 2W equal to 2 times the quantity W minus 8 minus 2. So the first thing we're going to do is we're going to distribute the minus 3 and also on the other side the positive 2 so that we can eliminate the parentheses. So when we distribute the minus 3 on the left-hand side, we have the following. Negative 3 times negative 6W is going to be a positive 18W because the minus cancel. And then when you take the negative 3 times the added W, you have a minus 3 and a positive 8. And that's going to give you minus 24W. I don't know why I said W. Minus 24. Sorry. So when you take the negative 3 times the added 8, it gives you negative 3 times 8, which is 24, minus 2W. And then when we distribute the minus sign, the 2 on the other side, we get 2W. And then what's 2 times negative 8, or subtracted 8? That's going to give us minus 16, minus 2. And then on the next step we're going to do is combine like terms. So when we combine like terms, we have an 18W minus 2W, which is equal to 16W minus 24 equal to, and then on this side, minus 16 minus 2 is going to give us the 2W minus 18. Since it's a linear equation, we want all the variable terms on one side and the constants on the other. So 2W and 16W, I'd like them to be on the same side. So I'm going to subtract the smaller, so I'm going to subtract a 2W from both sides. So when I subtract a 2W from both sides, on the left-hand side, the right-hand side, it cancels. And here when I subtract a 2W from both sides, I get 14W. And so we get 14W minus 24 equal to minus 18. And then I have the negative 24 and the 14W, so I want that negative 24 or subtract a 24 on the other side, so I'm going to add a 24 to both sides. On the left, when I add that positive 24, it's going to cancel with that subtracted 24. And then that's going to leave me with 14W. Let me move this so you can see. Now you can see, so you'll have a 14W equal to negative 18 plus 24, which leaves us with 6. And then we would divide both sides by 14, since the 14 is multiplied by the W. And so when we divide both sides by 14, we can reduce on the right-hand side, because we have 6 over 14 and they're both even. And so the 6 divided by 14 can be reduced because 2 goes into 6 3 times and 2 goes into 14 7 times. So we have W equals 2 goes into 6 3 times, so I'll have a 3 in the numerator. And 2 goes into 14 7 times, so I'll have a 7. So W equals 3 7ths. Question number 2 says solve the absolute value inequality 7 times the absolute value of y minus 3 plus 5 greater than or equal to 26. And so what we want to do is we want to get the absolute value expression by itself. So I want to subtract a 5 from both sides, so that'll give me a 21. So I'll have 7 times the absolute value of y minus 3 greater than or equal to 21, and then divide by 7. So let's capture that using math type. And so again, we have 7 times the quantity y minus 3 greater than or equal to 21. Then dividing both sides by 7, we're going to get the absolute value of y minus 3. The 7 will cancel. And 21 divided by 7 is 3. And then once we have it in this form, we can rewrite the expression anytime we have an absolute value greater than or equal to 3, which is a positive number. Similarly, we can rewrite it if we have absolute value of y minus 3 less than or equal to a positive number. So this is how this inequality can be written as two separate inequalities. So we're going to first take the y minus 3, and then what I'm going to do, since I've dropped the absolute value bars, I'm going to change this inequality symbol to less than or equal to minus 3 or the second equation is y minus 3 greater than 3. I said greater than 3, but I meant to say greater than or equal to. So it turns out the parent inequality absolute value gives birth to two children. The first one has the symbol reversed and the opposite of the number. And then the second one is identical to what you have to begin with. And it's true as well when you have the less than or equal to, except for the conjunction that combines them, or the connector. Instead of being or, it's and. So what I'd like to do is just show you what it would look like if it were indeed less than or equal to. So I'm going to copy this, and then I'm going to change it to less than or equal to, just to show you what you would have if we did change it. So I'm using math type to do this. So if we had less than or equal to 3, again, we would change the inequality symbol. So instead of being less than or equal to, we would reverse it. It would be greater than or equal to. And again, the sign here would be the opposite. And then the connector would be and. And then the second child, as I would say, from the absolute value inequality becomes y minus 3, the same symbol, less than 3. So let's go back and solve the one that's in the problem for today. So what we're going to do is we're going to solve each inequality separately. So to solve this one, by the way, even though we solve them separately, we do the same steps. For this one, I want to get the y isolated, so I'm going to add a 3 to both sides. So when I add a 3 to both sides, it's going to cancel on both sides, because negative 3 on both sides is going to cancel, and that's going to leave you with a 0. So it's going to be less than or equal to 0. And then we're going to write down our connector or. And then when we add 3 to this inequality, same thing, we add a 3 to get rid of the negative 3. Well, it turns out when we add a 3 on this side, we're going to get y greater than or equal to 6. Similarly, if we had this other problem where we had less than or equal to, we would again do the same thing, add a 3 to both sides. So when we add a 3 to both sides, they're going to cancel on both sides. For this particular problem, we'd have 0. And here, when we add a 3 to both sides, we'd have 6. So with or greater, sometimes I say greater, greater or, so greater than inequality absolute value, you're going to have the or statement. Less than, you're going to have the and is saying everything that's greater than 0 and less than 6, which is a tweener. So sometimes you'll see the second one written this way. Everything that's less than 0, all values of y that are greater than 0, and also less than or equal to 6. So sometimes you'll see it written as a tweener. So it's everything in between 0 and 6. So I hope those two problems help you with the sample final. And I'll do another one to show more problems.